Hi everyone, in this video we are going to solve a very nice algebraic equation, that is square root x plus square root 2x minus 1 plus square root x minus 2x square root 2x minus 1, which is equals to a. Here are the given conditions for a, that when a is equals to square root 2, when a is equals to 1, and the third condition is when a is equals to 2. So this is a very nice algebraic equation of International Mathematical Olympiad. So we have to prove that for what real values of x is the square root x plus square root 2x minus 1 plus square root x minus 2x square root 2x minus 1, which is equals to a, and given that a is equals to square root 2, a is equals to 1, and a is equals to 2, and here only the non-negative real numbers are admitted for the square roots. So the two terms are clear, that the values of x are real and non-negative. So from this, square root supplies that x will be greater than equals to 1 by 2. So this is clear. So now next we are going to solve this equation for the values of x, and this is clear that the values of x are greater than equals to 1 by 2. So we are taking the square on both sides to cancel the square roots. Square the both sides. By squaring the both sides, we get a square is equals to square root x plus 2x minus 1 plus square root x minus square root 2x minus 1 whole square. I am using the identity a plus b whole square here. I will get x plus square root 2x minus 1 plus 2 times x plus square root 2x minus 1 whole square and square root x minus 2x minus 1 and plus x minus square root 2x minus 1. So I can cancel this plus and minus. X plus x will be 2x plus 2 x plus 2x minus 1 and x minus 2x minus 1. So here I am going to solve this term. You can see here these are the same, x 2x minus 1 x 2x minus 1. Here is the difference, plus and minus. So I am going to use the identity a plus b into a minus b, which is equals to a square minus b. So I am going to use this identity here. 2x plus 2, this will be whole square root x square minus square root 2x minus 1 square. So I can further write it as plus 2 square root x square minus 2x minus 1. Further simplify it, plus 2 square root x square minus 2x plus 1. This will be, so I can write this as, this is an identity, x minus 1 whole square root. So this can be write as 2x plus 2 x minus 1 whole square. I can take 2 as common, plus square root x minus 1 square. So here is the value of a square, which is equals to 2x plus square root x minus 1 whole square. So by using the property here, to write this by using the property as x square root is equals to x mod. So we get a square is equals to 2x plus x minus 1 mod. So this is the final equation that we get. Now by solving this equation, we can find the value of x which are required, which must be real and non-negative. So a square is equals to 2x plus mod x minus 1. So here are the two cases for this. The case one is when x is less than equals to 1, and the second case is when x is greater than 1. So we will find the values for both cases. So here we are going to consider the case 1. When x is less than equals to 1. When x is less than equals to 1, then x minus 1 mod will be, if x is less than 1, then we can write this as 1 minus x, because x is less than 1. So and the equation reduces to, what was our main equation? A square is equals to 2 times x plus x minus 1 mod. So this equation will be reduced in this case as a square is equals to 2 x plus, I'm going to replace this 1 minus x here. This is reduces to a square is equals to 2. So the first case that is given in the question, that is a part, which is the value of a is equals to square root 2. So here this is precisely the same as part 1, a is equals to square root 2. Now we are moving towards the second case. The case 2 is if x is greater than 1. If x is greater than 1, then the value will be same. X minus 1 mod is equals to x minus 1. So we can write the equation, the main equation, a square is equals to 2 times x plus x minus 1 mod. We can write it as x plus x minus 1. So x plus x will be 2x minus 1. This will be 4x minus 2. What I have to find? I have to find the value of x from there. So x is equals to a square plus 2 by 4. So this is the value of x, and x must be greater than 1, as here we are using the second case that x is greater than 1. So this is greater than 1. This implies that this is also greater than 1. From there, a square plus 2 over 4 is greater than 1. So this implies that a square plus 2 is greater than 4. A square is greater than 2. A square is greater than 2. So for the values of a, we have the three values of a. For a is equals to square root 2, a is equals to 1, and a is equals to 2. So this is not true for any case. So square is equals to 2 has no solution. What we have to here use then, since we must have a, so this case has no solution, so we must have a square must be greater than or equal to 2. So for C, the third case, that is a is equals to 2, we have a is equals to 2. So which means that a square is equals to 4. This implies that a square is equals to 4. So the only solution in this case, if a square is equals to 4, x, as we know that, finally reject that x is equals to a square plus 2 over 4, which is greater than 1 here. So I'm using it for this. A square 4 plus 2 over 4 is equals to 6 by 4. So this is equals to 3 by 2. So there is the only one solution that we get, that x is equals to 3 by 2.